Next up, we have Vibhu from the R&D team at Avail, and he'll be speaking about Nexus, the coordination layer between all L2s. And their goal is really to unify rollups and data shared between them through Nexus. So welcome, Vibhu.
Hi, everyone. Thank you. So I'm going to be talking a little bit about Avail DA today, and then I'm going to move on to Avail Nexus. If time permits, we can probably dive into the technical aspect of it as well. So yeah, talking about the problem, right? Rollups do need DA to scale. We've accepted quite a while ago that rollups are the way to scale blockchains, but the bottleneck at the moment remains to be data availability. And they are hungry for DA, in other words. With the increase of the number of rollups in the system, like today we have so many general purpose rollups, and we're already talking about like app specific rollups in the near future. And with thousands of maybe like lakhs of rollups together, the UX is really fragmented. And I'm going to dive into why the UX is exactly fragmented in a little bit. But yes, the UX of different rollups need to be unified for them to really be composable at the end of the day. So the big picture. So Ethereum rollups today have the center stage, but dank sharding is like really a couple of years away, to be quite honest. So at the end of the day, like when we talk about data, the only like real way to verify data availability is to download all of that data so you can verify it. Which means with the current like data availability chains out there, the only way to securely like talk to any chains at the end of the day is run a full node, download all the data, verify state transition functions, and then verify the chain efficiently. So this is what allows DA solutions like Avail to enter. Avail today has KCG commitments that allows you to sort of verify data availability with light clients through KCG commitments at the end, towards the end of it. So how KCG commitment work? Maybe we can catch up after this, and I can probably explain it to you a little bit in detail. But TLDR, what KCG commitments allow you to do is perform data availability sampling and verify that the erasure coding has been done correctly without having to rely on fraud proofs for the same. Yeah. So how do you like solve the UX fragmentation, right? The only true way to solve the UX fragmentation with so many rollups is basically to allow interoperability in a trust minimized way. How do you reduce trust? How do you verify that rollups state transition functions are correct? That's what brings us to Avail Nexus. I'm going to talk about Avail Nexus. I'm going to dive into how we are like working on Avail Nexus to coordinate state routes between various different rollups, and yeah. So when you are coordinating like the state transition functions between various different rollups, it's important to have a shared economy guarantee, and that's what Avail Fusion is all about. And we are not going to be talking about Avail Fusion today. So if you guys have any questions, you can catch up with me right after. Yeah, Avail Nexus. So like I was saying before, today we have like hundreds of rollups, and soon it's going to be thousands of rollups. So how do you verify whether a state transition function of a rollup was executed correctly, right? The only true way to do that is you either run a full node or you run a light client to be able to verify that. Generally, light client have some assumptions based on which they work. Today, like some of the bridges that we see have just verify multi-sigs that allow you to trust those like attestations that a certain state transition function was performed correctly. So what that means is if there are like, let's say hundreds of rollups that want to talk to each other, each one of them have to run light clients of each other rollup that they want to talk to, which is a huge problem, which is something that's going to blow up quite soon, right? Because each rollup have like very different mechanisms of working, which means they need to have like a very different verifier implementation that needs to be deployed. So when I want to talk to a new rollup, that means I need to like create a new light client, or I need to like create a new smart contract which I deploy on a chain, and then I need to be able to run that, and I need to do that for each and every rollup that I want to talk to. So like this is the main problem that we are trying to solve with Avail Nexus, right? So Avail Nexus is a coordination layer, and if you want to talk to any of the rollups in the ecosystem, all you have to do is plug into Avail Nexus. So how does this work exactly? Going back to my point about how, at the end of the day, the only way to talk to a rollup is to verify to run a light client verifier that verifies the state transition functions. So what Nexus embodies is the idea that you don't really need to know what the state transition functions are. You don't really need to know like what transactions took place on a different rollup. What you need to know is the end result was something that was correctly executed. And if you're able to verify that, and if you're able to extract relevant events for you that you require to perform your state transition functions, that's all you require at the end of the day. So Avail Nexus. Summary of Avail Nexus. Avail Nexus is a rollup on Avail, which basically performs proof aggregation, aggregates various different validity proofs of different chains into a single proof. So all you have to do is verify a single proof to tap into any of the rollups in the ecosystem. Also soon we will be working on sequencer selection. So there will be auctioning and coordination for decentralized sequencer selection. Okay, so talking about Nexus a little bit more in detail. So at the end of the day, for any trust minimized communication or composability, verification is the key, right? What that means is basically you need to be able to run like light client verifiers of various different rollups. And the problem again with that is if you are working, like if you have a general purpose rollup, let's say an EVM based chain that is doing this, at the end of the day, what happens is like you have various different types of verifiers, which means you're sharing the execution environment with like so many other rollups, which will slow down the system. So Nexus itself is not a Turing complete execution environment. What that means is that it has a very single, like it has a single type of verifier, and it knows only how to run that single type of verifier. What this allows us to do is basically use advanced like proof aggregation techniques, and also like be more performant as a result of that. And but here comes the problem. If all rollups today are like built using different proof systems, if they are built using like various different SDK stacks, then how do you like at the end of the day verify it using the single type of verifiers? So this is some of the work that we've been doing with RISC Zero, and this is where RISC Zero comes in. So an important part of Nexus is the Nexus adapters. So Nexus adapters are just the light client verifiers at the end of the day, but they are light client verifiers which also provide validity proofs of having done their verification correctly. What that means is, like, for an easier analogy, they are smart contracts that you would deploy on Ethereum, but instead here you run it on your side, on the rollup side, and then you provide validity proofs of having done the verification correctly. So what this opens up is, at the end of the day, like all these adapters convert like various heterogeneous proofs into a single type of proof that can be submitted to Nexus, and that can be something that Nexus can understand. Also, what this opens up is these are the same adapters that can be used to submit proofs to Ethereum as well, which means the Nexus adapters and the state transition state roots that the Nexus will be accepting and the state roots that the Ethereum will be accepting will at the end of the day be the same thing, because it's the same verifier. So like here's again just an image to make that analogy a bit easier. So how verifiers are on Ethereum today is you have a smart contract. On the smart contract you have like various different implementations, and each rollup basically submit their proofs, they execute that verifier, and they're able to update their state root on Ethereum. how that will look with Nexus is you are running a Nexus adapter on your side. You're executing the same verifier, but you're generating a validity proof in a format that Nexus can understand. Now Nexus is running its single type of verifier for all these rollups. On successful execution, what it does is it basically updates the state root within its own state, which means by reading Nexus's state root, you can basically derive any of the rollup state root that you want or that you're interested in. So how are we, why is RISC Zero important to us, and how are we working with RISC Zero on this? So at the end of the day, we want anyone to be able to define these adapters. If you are building your own app chain, that it means that you should be able to define your own adapter like the way you do on Solidity smart contracts today. So with RISC, if we go the circuits route, the problem is the learning curve is definitely very high, which means it takes you a lot of development time to be able to define your adapters, generate the proofs in the format that Nexus wants it to, which is exponentially reduced by using something like RISC Zero. Also, something that I've personally found, like RISC Zero's aggregation is quite efficient. We haven't found the need yet to like optimize on top of that, but maybe soon we will. Yeah, and one more thing is rollups who don't want to run the adapters on their side can also use something like Bonsai to be able to offload the proving to shared prover. So yeah, that's it, guys. Any questions? That's the problem at the moment, to be quite honest. Like, we are working on CDK, on integrating CDK, so that we can have an adapter implementation that people can look up to and implement their own. But it's a bit complicated because all the rollups are at the moment moving quite fast. They're making like constant changes, and to be able to keep updated on the upstream changes is sort of the difficulty we are facing. But yes, we already have implemented verifiers for ZK Sync, for CDK's FFLonk. So yeah.
I have a question on like the interoperability piece. Like when we think about coprocessors, like there is, I guess, like some form of interoperability as where like builders can choose to post proofs on chain. How does that type of interoperability differ from the interoperability that like Nexus is unlocking?
So with Nexus, the main thing is that at the end of the day, like when you have co-processors, it still leads to a lot of fragmentation. And the reason I say that is because generally the solution we have today is like using a general purpose chain where you define your own verifiers, which means to be able to tap into another rollup. At the end of the day, what you have to do is understand how that rollup works on your chain, which is the bottleneck, to be quite honest. So with Nexus, what happens is you are basically enforcing a standard through the adapters that everyone else will follow when they tap into the ecosystem, which means you can essentially verify any state root that you want to and be able to verify any event that was generated within that chain. Thank you, everyone.